Okay, dear student, continuing the power protection unit, in this part we reach the protective relay. The protective relay are the devices usually installed, not usually, installed in the power system in order to protect power system against high voltage, high current, over frequency, under frequency, over thermal, under thermal, sometimes about the directional way of the flow of the power, which is directional flow of power. Other relay I can mention are uh, overload and blah blah blah. So many relays available in the power system. So first one is overcurrent relay. As the name is very clear, it detects when we have excessive current. So if the current is excessive, our means the overcurrent relay will operate. So right now the question is, what is the major difference between overcurrent relay and uh, overcurrent relay and MCB, miniature circuit breaker? Okay, to answer this, you can imagine this one. The power system, in the power system, the currents rate are very huge compared with the homes and even industrial application. On the other way, I can say in the transmission line, okay, we have huge current when it reach to the which send the power to uh, home appliance and industry. So this is industry, these are homes, okay? So these home and industry usually protected by MCB or RCD or fuse or other form of protection devices, which are small compared with the overcurrent relay. Overcurrent relay itself, it's something look like a laptop or look like old-fashioned of computer PCs in the small form, of course. Then it connected means a city is connected to that one, and okay, here I can highlight, and then okay, this is city which is connected, and this is our current relay. So how it's work is very simple. If we are in the normal condition, the current going through here, normal condition without any fault, okay? This coil, which energize the relay coil, okay? The energy for this one is very small, very limited. Then, if the fault current increase, okay? If the fault current increase, the current here increase, and then this coil become fully energized and can absorb this one going down, and these two contact touching each other, and then the other contact, which is coil trip, is here, coil trip, okay, will energize this one, which is circuit breaker, and circuit breaker will open or close any circuit. So for your information, MCB included all important parts to remove the fault in the power system. But overcurrent relay needs circuit breaker, need coil trip, and need extra and auxiliary devices in order to operate correctly. And then MCB price is in the case of maximum, in the best way I can set 500 ringgit Malaysia. Oh, it's very expensive, of course. I talk about the very professional one. Even you can find here in Malaysia by 50 ringgit, okay? Depend to the current. But for overcurrent relay, it's something around 700,000 ringgit Malaysia. So you can compare which one. It's only the relay, overcurrent relay. I'm not talking about circuit breaker, CTs, coil trip, and the other part of our protection system. Okay, only and only over current relay, which I think you will saw over current relay by the next semesters, year three, semester one or two in power system operation control. So you will see in the lab a relay, static relay, which you use it as the overcurrent relay. So the idea behind that, I can explain is something look like that one. Okay. Next, next relay is I think the name mentioned by here. I don't know why this one. This one should be in the next page. Uh, Distance relay. As the name of distance relay is given, it should measure the distance. But how we can measure the distance? Using only voltage and current. The distance relay using, as I mentioned, using only voltage and current. So voltage and current, familiar with the x, which is distance. How possible? The answer coming in this way. When we have voltage over current, what is the value here? Correct. Yes, it is Z or impedance. Then impedance of the line is related to X. What's the meaning of that? Assume this is the beginning and this is the end of a transmission line. This is transmission line. So we know 1 meter of transmission line has own resistivity. Assume is a small one, 0.001. Okay, this is somehow the R for this transmission line, ohm per meter. Okay, then if this transmission line length is 200 kilometer, what is the total resistance of transmission line? Yes, correct. So the R total is equal 0.001 times 200, which is 0.2, if I'm not mistaken. Okay, so ohm per, again, this is per meter and this is kilometer. So we have to convert also that one. So later you can convert that one. Okay, I want to say, I want to say if the length increase, the z increase. If the length x increase, z increase. So there is a unwritten relationship between x and z. So that idea is coming for a relay which is called distance relay. This relay measures impedance to detect the fault at a specific location. So distance relay has three zones. Normal distance relay. The relay can have 5 zones. Okay. So here, as a normal one for your level, only 3 zones. Explain. Zone one, which is the very fast one, we call it instantaneous, okay, operation, covering 80% of total transmission line. What's the meaning of total transmission line? This is the transmission line. This is the first one. The relay is here. This is distance relay. So 80%, this is the beginning until here. So 80% of transmission line covered, 20% uncovered. And there is a scientific reason behind that one. Later I will explain. Zone 2, it's 120% of protected transmission line. This is protected transmission line. Guys, I try my best to make you familiar with the names usually given to the first line. This is the first line. Total impedance, 120% of the first zone or whatever they can call it. Okay, so 120, it means that we have other transmission line. Okay, so 120 is 100% plus 20. So become 120%. Since here to here is 120%, and the last one is 140% of the first one. So it is going to cover many different type of faults. So the question arises why we should protecting only 80%, not more, not means why not 90%, why not 100%? The reason behind that one is when we have fault in transmission line, because mostly 99%, 99, 100%, the distance relay is used for transmission line, not for generator, not for motors, not for transformer, only and only to protect transmission line. But the others can be included in, okay? So the main priority for distance relay is a transmission line, sometimes transformer also included, okay? Then if we cover 80% of that one, again, why not 100%? In transmission line, usually the fault nature are from birds, from lightning, from a single line to ground fault, from trees, blah, blah, blah. So we have the impedance of fault, or in an easier way, we can call it resistance of fault. So in the case, resistance of fault usually increase this one. What's the meaning of 80%? I said 80%, 80% of X, which is total transmission line, correct? On the other way, we can set 80% of total impedance of transmission line impedance. So if we have another type of RF, which is fault resistance, okay, it will add it to this one. So on the other way, in the easier way, I can set by 80% plus a resistance of the fault, we are going to cover 100% and more of transmission line. So 80% is given because of the safety of protection. In another way, I can explain using the plane of R and X. This is R, this is X, and this relay is something look like a circular. So they usually set the total transmission line, the total transmission line, let me change the color. The total transmission line is from here to here, okay? This is the total transmission line we cover. So if there is a RF, extra RF, it coming to here, so it is not covered inside the zone. All distance relay need to operate and will operate when the fault come inside the zone. Okay, if it's outside the zone, will not operate. So because of that, they assign 80%. So there is the other reasons behind that one. Later in the chapter of the, I think chapter 3 or 4, I will explain about that one. Next relay is differential relay. What is differential relay? In the case of transformer, very expensive part of power system, such as transformer, generator, and motors. Okay, we using this one. We using differential relay. Differential relay is in the way that we have something, whatever is transformer, generator, or motor. Okay, and then we check the total current going in and coming out is exactly the same. Operation of this one is exactly the same as RCD. Okay, and somehow I can mapping that one. So if this is CT, current transformer number 1, and this is the other CT, current transformer number 2. If CT number 1 current is exactly the same as current transformer number 2, so the total current will be neutralized by each other, correct? This one and this one. So the operation coil is here. So if the current of CT1 and CT2 exactly the same, okay, maybe this is the better way I can explain. Exactly the same, they should neutralize each other, whatever this way or other way. I can explain both. This one not operating, but in the case of fault inside transformer, inside motor, and inside generator, what's the meaning of inside? In the coil, inside the body, not inside the transmission line, means just after, not before. Okay, this relay will operate. This type of relay usually called unit protection. Unit protection. Okay. The other relay we are going to explain is called directional relay. Directional relay operation is in the way that we must send the current or power only in one way. So the opposite way is not acceptable. In this relay, okay, in this relay, if the current or flow of power change, the relay send order to the circuit breaker and at the same time 1, 2, 3, 4 will operate and whole transmission system become off. Neutralize the fault. So how we can detect the direction of the relay? Of course, you have seen the old type of meter, electrical meter, which there was a disc inside, not the digital one, the old one. So that old one are one of the example. The rotation is clockwise or counterclockwise. This is clockwise, counterclockwise. Okay. Uh, can show you the direction of the current. So that idea is what we call it one technique to detect the flow. Of course, there are another techniques. That one is an old physical type. We have digital type to detect the direction of current or flow. Okay, right now, our power system changed to active distribution system. What's the meaning of active distribution system? This is the main bus bar. This is the main substation near your house. Then this is the transformer in, and after that one, there is electricity for you, which you are living here or here, okay, whatever. Then the new type of car, which are EV cars, can be charged at a time or they can discharge anytime we need. So it can be charged anytime or discharged based on the operator of power system decision. Then we have the new system. We have solar panels. So solar panel can generate energy. So we have energy on this way, we have solar panel, but solar panel usually 99%, okay, 99.5% usually they don't use any energy, otherwise they are broken, okay. Then we have somehow storage in power system, which are battery or hydrogen system. So that one can be charged and discharged anytime. We have the what we call it a smart house, which using the solar and the energy storage, and the other one you can see. Okay, so the power system totally changed. We need to protect this power system all the time. So for protecting the power system, we can use relay plus circuit breaker. So relays need circuit breaker. Without circuit breaker, they cannot operate. Okay, or we must use fuse. Have you ever seen any fuse? The fuse are old-fashioned type of protection. What is the major difference between fuse and circuit breaker? Usually the fuse used in the lower voltage level, not more than 50 kilovolt or 60. Okay, but Circuit breaker and relay can be used up to 1200 kilovolts. Okay, and then another major problem is after fuse operation, after detecting fault, we have to replace the fuse. Okay, we have to replace the fuse. But in the circuit breaker, we just need to reassign it. Means just reset it and use it again. New type of fuse also available in the market which can be reset, but the old fashioned for sure they must be replaced. In the electrical machine lab and power protection lab, I will show you the old fashioned of the fuse which must be replaced when they operate. So in the case of overcurrent, both system, whatever circuit breaker relay or fuse, operate, but the fuse must be replaced. The circuit breaker can be reset. Another things I can mention here, circuit breaker and relay are very, very expensive compared with fuse. Fuse is very, very cheap. These are the fuses available in the market. So this one I will show you in the lab. I think you can find this one inside the car. Yep. These are the this is the what we call it transformer. So we have a type of fuse. This is somehow the handle, and this is the fuse. We call it cutout fuse, and these are the normal fuses available in the market. I think you saw this one inside some extension cord, power cord extension available at home. Uh, Another important feature of the fuse is because the fuse is something look like this one. Okay, let me these are the conductors, and inside this there are another type of material, another type of wire with a lower rate of with a higher rate of resistivity. It means that will operate and melted in a lower time, correct? And inside this one is filled with material such as quartz or soil or somehow other material, salt can be, okay? So the action of that one are to quench the arc of the fault. So when we have fault, we have an arc. Just look at this one. This is the current and this is the time. Assume we are in a normal operating condition, okay? The current is very, very small at home, at your home. Without any fault, the current is 1 amp, which is a small value, okay? When a fault executed in the system, the current significantly increase, you can see, suddenly, okay? One cycle, half a cycle is since here to here, which is 10 millisecond, okay? So here is even less than half, you can see. Here is a 5 millisecond, and here is a small a small value of time. Then the fuse or other protective devices must operate. We cannot leave the fault current to reach to the maximum, which is here. Okay, in a short while it will reach to the very dangerous value, and it's very dangerous even for you and protective device, which is fuse. If it reaches such a high value, suddenly explode. So we don't want such danger happen for anybody. They set the current value, you can see cutoff current, and the time. It means that if the current increase and the time is set up by here, that material, this material inside the fuse start to be melt. And then this is the melting point. This is the highest time, okay? And then during the melting, of course, we have arcing, so the arc still conductive. And then the current drop because of the arcing. Drop, drop, drop to zero. So what's the meaning of this process? In another way, I can explain in this way. Just look at this one. This is pre-arcing time. We call it pre-arcing time. It's the time that the fuse is detecting. Still not sure. Should I operate? Not. What should I do? Okay. And A is the time that the fuse find the fuse finds out must operate. Okay. And then after that one, we have arcing time. We have arcing time. This is called arcing time. The total procedure is called total operating time. You can see total operating time. So these names are very, very important. Pre-arcing time, arcing time, and the most important is total operating time. Why? Later I explain what's the meaning of total operating time. But look at here in another way. When the fault start, when we have the fault, okay, this is the normal voltage in power system. You can see our current is very small, but we have the voltage in a normal condition. Just after that one, when the fault initiate means from this point the fault initiate until reaching to the maximum, correct? Okay, our current increase but the voltage drop. You can see the voltage is dropped to here. It's not zero but it's drop. Okay, then at this point when the arc start, okay, again we have what we call it arcing there. So the arcing increase and decrease the voltage. So here we have unusual type of voltage, and then at this point the current reached to zero. So from here suddenly we drop to zero because it's cut. Two part of fuse become open. So inside become look like this one. This is our fuse and this is melted. Okay. So there is no current, no voltage. It look like we switch off. The most important, as I mentioned, the most important one for the fuse is uh, total operating time. And another things which is very important, the fuse must carry the normal operation current of the system. Assume we have a heater which needs 6 amp. Can we use a fuse as a 5 amp? So we cannot. Why? Because at the normal operating condition, after a while, it's 6 amp. Okay, the fuse is 5 amp. It will be blown and burned out. So the step one, we should choose the best current. Okay, the best current close to operating current. What's the meaning of best current close to operating current? For fuses, there is a settled classes available in the market. You cannot go into the market and say, okay, the current of my devices is 5 amp, so I'm searching a fuse for 5 amp. No, in the market, I think the list of that one given by me somewhere. Uh, mm, I think if it's not, I will provide it for you because okay, of course, different what we call it manufacturer, different standard, but whatever it is available in the market, and you cannot go to market and ask them for your specific value. So step one, the most important step one is the nominal current of the fuse, then nominal current of device. So nominal current is the most important one, step one. Number two, for fuse coordination and fuse picking is I to T. What's the meaning of I to T? I2 is the current, total current, which going to melt this material, and I2T is called as the energy needed to melt the whole material. Means from this point pre-arcing happen, and by this point, okay, by this point what happened, by this point the total operation is done, is exactly this. pre-arcing happen, and then the total operating time. So for any fuse you are going to choose, you must consider the current. You can see the current given by here is example 80, 100, 125, and 160. Of course, the value less than 80 available, the value over 160 also available in the market. And if we are going to do the coordination of the fuse, what's the meaning of coordination of the fuse? I have one fuse by here, I have another fuse by here. This one is the fuse inside my house, okay, controlling everything. And this is the fuse of my power cord extension. So this is assume 16 amp fuse, and this is 30 amp fuse. Or to be better, assume this one, I change it to, I want to show you something. I change it to 80, oh sorry, 80 amp. So how can we choose the backup for here? Choosing backup is very, very important. If we choose 80, so the nominal current can carry by this line is 80 amp. Okay, correct? Then for the backup, which is here, okay, we cannot choose 100 amp. Assume this one only 10 amp. The total current here is 90 amp, okay? The total current here is 90 amp. We cannot choose 90. Even we cannot choose 100. Why? The current is in the range, correct? But I power of 2 T, which is the energy for melting the material, is not considered. Just look at here. At the time the fuse 80 amp is fully melted, the 100 amp, if we choose 100 amp by here, which is a good idea, okay, is more than half melted, 75% melted. What about the other one? Just check the other one, 125. 125, half of it is melted. What about 160? You can see 160 is not connected. So it means the only one we can choose as a backup is 160 amp. Okay, and this graph is a graph explaining the minimum melting time compared with the total clearing time curve. It means that at the minimum time, this is the minimum time started. Minimum time we're expecting to have melting is this one, minimum time based on the manufacturer. But the total clearing time, something happened here, something happened there, is this value. Is look like you said, okay, based on the GPS, I will be there by 10 minutes, but you face some traffic light, maybe somehow accident or something happened. So you reach to the point by 12 minutes. Okay, so there is a significant difference. You can see this curve. Maybe you said it is not a big one, but in the case of protection, it's very, very big one. You can see this difference is a big one. So the time Tm and To are totally different. When we choose something for coordinating based on Tm and To, something look like this happen. So the TM and TO are the most important. Usually we don't refer TM and TO, okay? We usually mention the time of operation for the relay. Here is only the graph. I'm going to explain what's the meaning of total clearing time and minimum. We must use this one. We must use the total, not the minimum one. Minimum one is the best one we're expecting to happen, but usually this one happens. Okay, I think for today is enough. I will cover this by the next uh, recording. Thank you very much.